What if I told you there's a planet in our solar system where landing isn't just dangerous, it's impossible? Not difficult, not risky, impossible. From far away, it looks calm, perfect, untouchable. But the moment you get closer, everything changes. The atmosphere turns violent, the pressure starts crushing you, and before you even realize what's happening, you're already gone. You wouldn't land. You would simply become part of the clouds. That planet is Saturn. And the truth is, Saturn only looks like something you understand, because the deeper you go, the more the laws of physics start to break. Saturn is the second largest planet in the solar system, surpassed only by Jupiter. It's so massive that more than 700 Earths could fit inside it. From this distance, it looks like a solid world, like something you could stand on. But that assumption is the first illusion. Saturn doesn't belong to the same category as Earth. It's what scientists call a gas giant. That means it isn't made of rock, soil, or any solid surface at all. Instead, it's composed almost entirely of gas, mostly hydrogen and helium, the same elements that make up stars. In other words, Saturn isn't a planet in the way we instinctively imagine one. It's more like a colossal sphere of swirling atmosphere, an endless system of clouds, storms, and pressure layers stacked on top of each other, with no clear boundary between sky and surface. And that leads to a question that sounds simple, but changes everything. If there's no ground, what actually happens if you try to go down? Before you even get close enough to find out, there's another problem: distance. Saturn is located more than 1.4 billion kilometers from Earth. That number is so large it's almost meaningless until you think about it this way. Sunlight, traveling at the fastest speed possible in the universe, takes over an hour to reach it. That same light takes just over 8 minutes to reach Earth, so even light struggles to get there quickly. Now imagine a spacecraft. Even our most advanced probes take years to make that journey. The Cassini mission, one of the most important space missions ever launched, spent nearly 7 years traveling through the solar system before finally arriving at Saturn. 7 years just to get there. And yet, strangely, the journey is not the most dangerous part, because the real danger begins the moment you arrive. At first, Saturn doesn't look threatening. Its outer atmosphere appears as soft, layered bands of yellow and beige clouds stretching across the planet. From a distance, they look almost smooth, even calm. But those clouds are anything but gentle. They are enormous storm systems, some stretching thousands of kilometers across, large enough to swallow entire continents on Earth. And hidden within them are winds that can exceed 1,800 kilometers per hour. To put that into perspective, the most powerful hurricanes on Earth reach around 250 kilometers per hour. Saturn's winds are not just stronger, they are on an entirely different scale. And they don't just pass through. They can last for years, sometimes even decades. There are events known as the Great White Spot, massive planetary storms that appear roughly every few decades and can grow so large they wrap around the entire planet. Imagine a single storm engulfing a world. Now imagine trying to fly through that. Let's say, somehow, a spacecraft survives this chaos. It pushes through the violent winds, stabilizes itself, and begins to descend deeper into Saturn's atmosphere. This is where the illusion fully breaks, because there is no moment where you arrive, no landing, no solid surface waiting below. Instead, the spacecraft would continue falling. At first, the surrounding gas might feel familiar, thin, almost like air. But as the descent continues, something subtle begins to change. The atmosphere becomes thicker, heavier, denser. You wouldn't notice it instantly. But gradually, the environment stops behaving like air. It begins to resist, to push back, to feel almost like a liquid. And that's because, in a way, it is. The deeper you go, the more Saturn transforms into something that resembles an ocean, except it's not made of water, but of compressed gas. An invisible sea with no surface, no horizon, and no bottom you can realistically reach. Inside this ocean, the pressure begins to rise. At first, it's manageable. Then it doubles. Then it triples. Then it becomes something your mind can barely comprehend. The spacecraft would start to feel it before anything else. A low, creaking sound, almost like the structure is adjusting. Then the metal begins to strain, panels bend, the hull slowly deforms under the weight pressing in from all directions. Electronics begin to fail as systems are overwhelmed by heat and pressure. Internal supports collapse, the structure weakens piece by piece. And then, at a certain depth, the pressure becomes so extreme that it doesn't matter how advanced the technology is. The spacecraft is crushed, not explosively, not dramatically, just compressed, silenced, gone. And all of this would happen long before reaching anything resembling the center of Saturn. Because deeper down, things become even stranger. Scientists believe that hydrogen, the most abundant element on Saturn, undergoes a transformation under extreme pressure. It stops behaving like a gas and becomes something called metallic hydrogen. This is not something we experience on Earth. It's a liquid that conducts electricity like metal, forming vast layers deep inside the planet. Entire regions of Saturn may be made of this bizarre substance, creating powerful magnetic fields and dynamics we still don't fully understand. And somewhere beneath all of that, there may be a small, rocky core, a hidden center buried under unimaginable pressure. But reaching it? That's not just difficult, it's essentially impossible. Now imagine something even more unsettling. Let's say, somehow, against all odds, a spacecraft manages to descend deep into Saturn and survive. Eventually, it would need to leave. And this is where the final problem reveals itself. Escaping Saturn is harder than entering it. To break free from a planet's gravity, you need to reach something called escape velocity. On Earth, that's about 40,000 kilometers per hour. On Saturn, it's roughly 130,000 kilometers per hour. More than 3 times greater. But speed isn't the only issue, because there is still no ground, no platform, no stable place to launch from. You would be trying to accelerate upward while suspended inside a crushing, chaotic ocean of gas, fighting against pressure, turbulence, and gravity all at once. Every second, the planet would be pulling you back down. It wouldn't feel like leaving a place. It would feel like trying to escape something alive. And this is why, despite decades of exploration, no human has ever come close to Saturn. Only machines have gone, and even they don't stay long. The first visitor was Pioneer 11, launched by NASA in 1973. At the time, Saturn was still largely a mystery. Scientists didn't even know if a spacecraft could safely pass near it without being destroyed by its rings. In fact, Saturn wasn't even the original destination. Pioneer 11 first traveled to Jupiter, using its gravity as a massive slingshot to propel itself outward toward Saturn. This technique, gravitational assist, allowed it to reach distances that would otherwise be impossible with limited fuel. In 1979, it became the first human-made object to visit Saturn. But visit is a generous word. It didn't stop. It didn't orbit. It simply passed by, quickly. In just a few hours, it captured images, measured radiation, and revealed new details about the rings. It even discovered a previously unknown ring. Then it was gone. because staying longer was too dangerous. Saturn's rings, as beautiful as they appear, are not smooth structures. They are made of countless fragments of ice and rock, ranging from tiny particles to massive chunks. All of them are moving at incredible speeds. A single collision could destroy a spacecraft instantly. After Pioneer 11 came Voyager 1 and Voyager 2, launched in 1977. These probes took advantage of the same gravitational assist technique, hopping from planet to planet like stepping stones across the solar system. Voyager 1 reached Saturn in 1980. Voyager 2 followed in 1981. They sent back some of the most detailed images humanity had ever seen. Saturn's rings turned out to be far more complex than anyone expected. Its atmosphere revealed massive storms, and its moons changed everything. One of the most intriguing discoveries was Titan, a moon covered in a thick atmosphere that hides its surface completely. Others were frozen worlds, scarred with cracks, ridges, and impact craters. Each one hinted at something deeper, something unknown. But again, none of the probes stayed. None attempted to descend. And then came the most ambitious mission of all, Cassini-Huygens. Launched in 1997 as a collaboration between NASA, the European Space Agency, and the Italian Space Agency, Cassini spent 7 years traveling through space before finally arriving at Saturn in 2004. This time, things were different. Cassini didn't just pass by, it stayed. For 13 years, it orbited Saturn, studying the planet, its rings and its moons in extraordinary detail. It confirmed that the rings are not solid structures, but vast collections of ice and rock fragments, constantly shifting and colliding. But its most important discoveries came from places no one expected. On Enceladus, Cassini detected enormous plumes of water erupting from beneath the surface, evidence of a hidden ocean beneath its icy crust. An ocean that might, just might, support life. And then there was Titan, a world with rivers, lakes, and rainfall, but not made of water. Instead, its surface is shaped by liquid methane and ethane, forming an entirely alien version of a water cycle. A familiar system, built from completely unfamiliar materials. And then, in 2017, the mission came to an end. Not because it failed, but because it had to. Scientists realized that if Cassini ran out of fuel, it could drift uncontrollably and crash into one of Saturn's moons, potentially contaminating a world that might host life. So they made a decision. They sent it into Saturn, deliberately. As it descended, the planet did exactly what it would do to anything that tried to enter it. Pressure increased, heat intensified, the structure weakened, and eventually Cassini was destroyed, crushed and torn apart by the very world it had spent years studying. But even in its final moments, it kept sending data. And because of it, we now understand Saturn better than ever before. Yet the more we learn, the stranger it becomes. Because Saturn isn't just a planet you can't land on. It's a place that challenges the very idea of what a planet is. If you enjoyed exploring the darker side of our solar system, consider subscribing, because out there beyond Saturn, the universe only gets more disturbing.